My name is Michael David. I work for Siemens Industry. I've been here for 30 plus years now, going on 31. My role right now, I work as what's called a senior network integration engineer. That's just a tag that Siemens puts on roles. I'm also called a component engineer. That's more the German role. But really what I do is I support, and I'm the system architect for the Siemens Zigo CC product at the enterprise scale. And in addition to that, I work in the Zone 6, it's called the Zone 6 design group. Siemens, a few years back, it was very non-traditional for them, made a decision to create what's called, they call it design group. Really what it is, it's a regional support group. And I am in the Northeast group that's based out of, actually our office is out of New Jersey, but we literally cover from Virginia all the way up to Maine, all the way out into Western New York State and everywhere in between. And my good partner in crime, Mr. Josh Morgan, is sitting next to me here, and he and I have seen it all, and you're going to hopefully get some really good info out of this, and a few entertaining stories for you, because I love to tell stories. I'm an Irishman, and I love to tell Irish stories. Before we begin this, I do want to thank Symmetrics for hosting these meetings, everybody for coming, and specifically going back to the meeting. And I was talking to Laurie about this. I think it was 2016. We had it at BU. It was the first one I came to, and Mike Newman came in. And that was the night that he said he made a presentation on BACnet best practices, I think it was. A lot of it had to do around broadcasts. A lot of it had to do how to keep yourself out of trouble. Little did I know that the following year there was going to be a major change in my career. That's when Siemens developed this role. And I was going to be introduced to this guy and go on to one of the biggest projects I've ever worked on that probably has in excess of 4,000 BACnet devices that are on it. Maybe more by now. Could be 5,000.
Yeah.
And along the way, I actually went to school of what I would call hell in a handbasket, real quick. Learned a lot about structuring BBMDs, what I call asymmetric broadcast domains versus linear broadcast domains, and all these little tidbits I'm going to give to you, along with what I've actually seen as net results of what can go wrong here. So we got a bit of stuff to go through, and that's what we're going to try and do tonight. And feel free at any point to stop me, ask a question, or what have you. So, what is the problem that we're talking about here? What we have seen, and it's becoming larger and larger, I would say over the last 2 years, we have had at least 2 or 3 projects a year, where it might be 1 a year, where we begin to have what I call mischief, okay? And this mischief is based on the problems caused by BACnet broadcasts. Now, I'm going to narrow the broadcast we're talking about here into a specific bucket. The primary problems that we've seen issues related to are the broadcasts that are used for auto discovery. If everything was statically bound, life would be grand. But unfortunately, nobody is. So you have, depending, and again, based on a lot of my experience here, I'm going to tell you it's based with the Siemens products. I know a lot of the men and the other folks in the room here are experienced with different products. I don't know if they behave the same way. I'm just going to tell you what I've seen. I'm also going to tell you a lot about what I've seen third-party products do. But in the Siemens world, our products use, for instance, the Who Is I Am discovery service quite extensively. And in the event that a device that it has discovered and bound to goes away, it then starts to do these rediscovery tasks that if you look at it from, oh, it's only a couple of devices that have failed. When I have a large system that may have thousands of devices that have not been partitioned from a broadcast perspective, hammering away trying to find those 1 or 2 or 3 or 4 devices that have died, you end up with an amplified broadcast scenario. So it's great, it's very vendor specific as to when or whether these broadcasts are sent. I can tell you Siemens does a pretty good job at creating a lot of noise, and I think Josh would agree with that. Yeah. We know reasons how to minimize it, but it's there. Static bindings, to any objects or devices, hey, that's the greatest way to eliminate it, but let's face it, you're not going to do it. And I think this is the biggest part to it, okay? In general, the exact conditions or triggers that create these broadcasts and broadcast event are very vendor specific, okay? For example, we've had cases, as we go into this a little bit, I'll start explaining what we've seen as the side effects, where we have devices that fail and go away on us, we restore them again, and then a day or 2 or 3 later, they'll fail again. In between, the operation is perfectly normal. So a lot of times what you think you've repaired, you really have not repaired, because what's happened is the broadcast storm that was triggered by some specific sequence has gone away, only to come back a day or 2 later unbeknownst to you, and unless you're capturing it or you're able to get on there at the time when it's occurring, you may miss it. This Jim Butler and I had discussed once, and this was an interesting fact to me. So when we start to talk about broadcasts and measuring them, we use a very simple test, usually using Wireshark. And what we do is we put a display filter in, looking for broadcasts, and literally we look at a 1-minute window and we count them up. I once asked Jim Butler in a conversation, is there a number in the standard that says what devices are tested to by BTO or what they should tolerate? And the answer is no. And at first I was a little taken back by that, but Jim pointed out it would be like trying to get all the vendors at a table to agree on what that rate should be on anybody that's developing a little tiny microprocessor and a pen like this, up to a guy that's working with basically a multi-processor chip and a server. So there is no magic number. I can tell you, we've measured some conditions, 3,000 a minute. Yeah. What's the top winner you would think?
10,000.
Was it 10,000 a minute?
That's enough to crush our devices.
Yeah, about 10,000 a minute. You start seeing Jim's shaking his head. Yeah, isn't that an amazing number? What's amazing is how hardy a lot of the devices are and how they survive, but the mischief that starts to occur. Okay. So again, I don't have a magic rate for you. I would tell you my personal opinion is that the broadcast rate in a perfectly normal system with everything that's working right should be that. And I've had numerous discussions with my colleagues over this. Okay, they look and maybe it's 5 or 10 a minute because there's some devices that are failed. Okay, I'm willing to accept that. We typically say anything that's 200 or less, we don't raise our eyeballs to. Anything that starts north of that, we begin to get concerned. And surely anything that's over 600 a minute, we definitely are starting to raise our eyebrows. These are real numbers, and they're no joke that in a large system that is not taking steps to control the broadcasts through the various methods we will talk about in a few minutes, you might actually see numbers that are 5, 6, 7,000 a minute. and it may very well explain to you why some of the misbehavior is going on with the end devices that are out there. So, I'm going to break this down into two different failure modes that we've seen. So everybody's got a handle on what I'm talking about here with the broadcast rate, right? And we've all seen the broadcasts that pop out. We've seen them occur. We may capture Wireshark for a while on a system, and you know, as we're filtering through, we see these who is, I am, who is router to network, I am router to network. We really don't ever take a lot of notice to that unless we're looking for broadcasts. But that's in reality what we're talking about here, is those broadcast level packets. The two types of failures we've seen are really dependent on the physical layer of the device that we're talking about. The biggest offenders are the guys hanging down on the MSTP wire, and there's a reason for that. They're typically using a 5-cent microprocessor with probably a free operating system, or maybe a bare metal roll their own with a very cheap BACnet stack. They might have not bought the Symmetrics one. They might have gotten Steve Cards, okay, which is not a bad, you know. But what they don't do, and this is where it's important to get a conception of this, and I'm going to give it a try. The harm to the broadcast, it's simply put, is this. Whether I'm at the IP layer or I'm at the MSTP layer, any broadcast that hits the wire on the physical layer that I'm on, that sends a broadcast message, my stack has to evaluate. And 90% of them I could be throwing away. Let's say I got a 2,000 a minute rate going on, and let's say, you know, 2 out of that 2,000 a minute are mine. Look at it, the majority of them are gold. The problem is I have to touch every one of them. And a lot of these MSTP devices, and I believe this is probably changing now with the ARM craze that's going on, were built on very cheap microprocessors that have very, very limited resources to them. Their stacks are very small. They're trying to cram them in a tiny amount of RAM, even in ROM. Even now, a lot of that's changed now. But the bottom line is their buffer that they have internally to store the unprocessed messages, and this is a theory I know is right. They get a message, the highest priority, they put it on that in storage, and then they go do something and come and get it. If I'm battering away at them, I really wanted to put a picture of like Muhammad Ali beating the crap out of somebody. They keep putting these messages in, putting these messages in, putting these messages in. If they don't get enough breathing room to go peel them, eventually the pot gets too full and they overflow. And a lot of those MSTP devices, when they overflow, they die. And I got a couple of fun stories to tell you about it. Best case, are the ones that simply fall off the wire. The displays may work yet, a lot of times they won't, or they'll just stop communicating. Sometimes they'll start sending you message postponed, reply postponed, over and over and over again. So the exact amusement that you'll get as a return to them dying is not well defined, but the only fix is a power cycle total. And somebody will actually tell you, as in, I think most of us in here are probably at the level where we're dealing with the customer doing this integration of these third-party products. Like it or not, when we sign the contract, we're the system integrator, so all the fingers are pointing at you going, when are you gonna fix it? And guess what? It's not my problem. But now the fun's gonna begin because I gotta prove it to you. All right, so here's another case. Again, I'm gonna go into the real case studies of these. So we got the type where I abuse the MSTP device and it dies and goes away, okay? My only recovery is I gotta go find it and power cycle. Then there's the type, and this was another joyous one that we saw. And remember, keep in mind, these broadcast pummelings that are going on may be coming and going. They're not necessarily linear at all times. They can be asymmetric. So there's another type that went on. This was with a different vendor, where these devices, when the pummelings would start dropping packets. So they would just randomly, as the broadcast rate would come up and go down, they'd stop listening to you. They drop some of your service requests, like a read property or read property multiple that you might be doing to check the status of them, and you think they failed. The next thing you know, you go back around, they've cleaned, and I think their stack overflows, they just flush everything. Next time I come back and I ask them again, well, this time he answers me. So guess what happens? I say, you're dead? Oh no, you're alive. So now I'm bouncing you in and out of failure. That's another thing that we've seen, where they bounce in and out of failure. They work, then they don't. They work, then they don't. That was another bit. Now, there was an extreme case, and this is the last bullet point that's on here. And I'm going to change the order here a little bit. Okay. There's an extreme case that I'm going to tell you is a case study, and this is the worst one, because I want you to look out for this. Because I don't think these guys actually ever fixed that problem, did they? They pulled those devices out on us, right? The Anacondas?
Oh, they added another one that was like detail listed, and they did a hardware.
There's a case, we've seen a couple cases where the device failures are so severe that when they fail, they leave the enable line for the RS-45 transceiver asserted. Nice place to leave it dead, and it just takes the whole bus and knocks it down. And now you're off on an Easter egg hunt trying to find who's got it hung. If you got an oscilloscope like we had, I'll tell you the whole story later. We found that only to have it reappear again like 50, and that's a whole nother story. So there are cases where these things will puke or die, and they'll actually hang the bus and take everybody else that's hanging out there with you with it. And now you're left on an Easter egg hunt going to find the one that's got you hung. So that's another one. Okay, so BACnet IP mischief that we've seen. We've seen cases, again, in severe broadcast conditions where advanced application controllers, devices that I'm going to download programming to or some type of custom control algorithms to. If I've got a high broadcast rate out there and my BACnet client, which is my Desigo CC tool, is trying to jam that programming down into them, it'll be clunking along trying to put it down, and all of a sudden it stops and it times out. And I've also seen this with third-party devices trying to do this. It's not as prevalent as the MSTP devices. They seem to be the worst offenders. And I think, again, that's because of microprocessors and resources and what stacks they're running. I think the MSTP devices are the cheapest ones that are done out there. Where you start getting up in the PCs, we have a lot more horsepower. But the field panels, a different story. I've also seen cases, which we were, I think, discussing before, which in a high broadcast rate, your application workstation, if it's getting abused by these, may start to get sick as well. And at that point, some of your functionality may not right. You may not get alarms. You may not sometimes get COVs, because again, you've got this tremendous amount of chattering and noise that's going on. And the problem is it could be coming and going, and you really don't, and now you're left on an Easter egg hunt trying to figure out what's broken, okay? So how am I doing here? Is everybody keeping up with this?
Yeah.
Okay. I've seen primarily, you can feel free to add anything else here I didn't remember. I've seen 3 BACnet IP services that are the 3 key cause of this problem. The who is I am sequence, predominantly the who is. The who is router to network, I am router to network. That one's got a special case because I've seen application controllers that as we're building bigger and bigger enterprise systems, the amount of BACnet networks that are out there start to get beyond, like I used to think, well, I've got 150 BACnet network numbers, that's crazy. I've seen jobs now with probably 500, 600, maybe even more. And what happens is some of these devices can only keep track of, they listen for all these who is router to network, I am router to network, so they know who's got what. And when their list gets overflowed, they go bang like that, and they go back and say who is router to network. So I'm in this constant loop of getting abused with who is I am router to networks, and that'll knock your socks off. There was a rare case, and I wish Larry was here. Unfortunately, he had to go to Pittsburgh tonight to deal with an emergency. But there was another case where we saw it. It was a non-Siemens product, and I'm going to leave all the company names out. I'm always going to start with whatever the first character of the company is, just to make it fair. But this company, I don't even remember their name, had set up a BACnet COV notification that was being sent as a broadcast, and had Jim shaking his head, yes, he might remember this, and had such a crazy COV that it was literally abusing everybody to death. And there was a reasoning why it was done that sounded very solid, but the reasoning of why they had it sending so much was not. So that's the, and are there any other ones that I'm missing? You remember?
We've seen confirmed COVs that with such a low rate, like you subscribe like 3 of them, and they're like to the millionth decimal place, and they just hammer it relentless. To the device to the point where they don't do anything else but that. That's the only thing.
But we didn't see any we didn't see any broadcast
Yeah,
back, so that's the primary offenders we've seen, right? Okay. So now let's get into observed conditions and what that means. And I want to make, again, I'm going to go back over what I just talked to you a little bit about. But the comment I'm going to make here is, and we were actually talking a little bit about this before. A lot of us deal, I think, in the scenario where we're dealing with customers that may be in the construction industry. I myself am typically dealing with my colleagues who are then dealing with people in the construction industry. And trying to explain these scenarios to them and what's happening becomes very, very difficult. Because first off, the people that I'm communicating in with, not my colleagues, but the customer, to be honest with you, they don't care about any of this. Convincing them that it's not my problem, it's their products, this other company's products problem, they typically don't want to hear because they're looking at me as the system integrator. And a lot of times, these problems may take hours or days for them to appear again. Particularly, you may see a situation where a particular, and again, I mean, it's a flow meter, it would die, you'd go and flip the power reset on it, you'd hunt it down, it would start running again, and you'd go back through one of these broadcast storms and it would go away, and somebody would finally discover it 2 or 3 days later. Good luck trying to convince somebody that that's not your problem, that it's, you know, it's somebody else's problem. The point I'm trying to make here is, don't think that these are instantaneous events. They're not, and sometimes they take a lot of Wireshark sniffing, setting a laptop up, leaving log files running in chunks, getting when the failure occurs, going back and peeling it apart to figure it out. Okay, so now we're going to start getting into mitigation methods, and I'm also going to mix in here some of the use cases. I'm going to twist a few things in. So here's the first thing I'm going to say. I'm going out of order here. Are there any professional engineers in here that are doing specification writing for anybody? Is there any PEs in here for any companies? All right, anybody that has an influence with PE, and I think, Jim, you were talking about writing specs?
Yeah.
big problem I got. The consulting engineer companies will absolutely state me on the head, you better be BTL. You better be BTL this, you better be, and we are, right? You know, Siemens, they don't make the third party guys that they're giving to me BTL listed. We have a saying when we start a caper, as I call them, is it BTL? We look it up. No, it's not. It usually means junk. I'm sorry, that's just the experience I've been. If I find that it's BTL listed, 9 times out of 10, I have a very reasonable shot at fixing the problem quite straightforward. Safe to say, okay? Okay. Now, I'm going to tell you a story here because I love to tell stories. Friday night at 5 o'clock, I'm working at one of the biggest airports in New York City. We're on what we called affectionately, we had another word for it, but I'll be nice here. I called it the prison camp. We were working 16-hour days, at least 6 days a week at that time, trying to build this 4,000 device monstrosity. We had already gotten through the wood saw mill once. Luckily, we had taken a step at the beginning of the job and done a lot of V-landing that later came on to become very handy to us because we didn't have enough time to really sit back and think that we were going to have to shape the broadcast traffic. And at this time, we were still co-joined with most of it in one particular VLAN, one linear subnet. I get a call from my friend here at 5 o'clock on a Friday night, and he says, "Hey, where are you?" I don't know where I was, at the other end of the airport. He says, "I got a beauty for you. Want to come over and take a look at it?" I said, "Sure." I go over to a power plant. We get on this MSTP bus, and he says to me, every once in a while, the whole bus goes dead. And I'm pretty sure it's that thing that's doing it. And the manufacturer was O, and it was a flow meter. And I said, "Oh, all right, well, off we go." Luckily, I had a digital oscilloscope with me, and you can get them darn cheap now. And I clip it on there. I've worked with RS-45 for probably 30 years back there when I worked on Monicon stuff. And the first thing I see when I look on there is I see that the bus is asserted, meaning it looks like somebody's pulled it up, and you see other people trying to talk. I go, "What the hell was that?" Well, we spin around a little bit, and I'll be honest with you, this did not come out. This took a couple of hours to figure this out. We figured out that if we power cycled this particular flow meter, things would go back to normal. We chased a few things around to make sure we had our terminations correct. It was a good check. But what it really came down to in the end was there was a little tiny board there that they had done their BACnet implementation on. They did not develop it, they had subbed it out to somebody. They used not a Symmetrics BACnet stack, it was competitors. And when we had this nailed down, they sent in a technical support fellow to come in and help us out, and he came walking in the door and said, "I'll have this fixed in 15 minutes, and all it needs is 2 resistors." And we were sitting there, and I think I asked him if he wanted to gamble and if he had his wallet in his pocket. And he didn't like that. He went off. He came back about 2 hours with a sad look. And what he really found out in the end was the stack was being abused by the broadcast. It was partly our fault. I mean, because it was the Siemens stuff that was barking. But at the time, as we're going to talk about in mitigation, there wasn't a lot I could do about it because there's other things going on. And this is my point. Jim Butler, please feel free to tear into me over this. I believe that if I'm making a BACnet device, whether it be MSTP or IP, there should be no reason that I could ever be abused to the point where I blow up and don't come back. I could see somebody dropping the traffic they had, their buffer gets full and they flush it and ignore it. But I saw more and more of these guys that just die and go away. And it's being almost given to me that this is normal behavior. I don't buy that. Okay. That case was probably one of the worst ones we ever saw. They could not fix that problem. They came in with other hardware, ripped it out, and threw it in the garbage. And guess what? It wasn't BTL listed, right? Okay. So what's going on in the next one? Now, again, more mitigation methods. And this one I didn't do a lot of writing about. I'm going to apologize for my slides. I was terribly sick Saturday. I wrote these while I was laying on the couch and my partner was feeding me chicken noodle soup because she said to me, Mike, you got to get to Boston on Monday. And obviously she did a good job because I'm here. When Mike Newman came in to talk to us in 2016, and I would think his presentation is probably still up on YouTube, correct? I would recommend to anyone in this room that has time, please go watch it. He did a wonderful job of presenting it, and his slides are beautiful. The problem we face is that if I take, and we've seen this done recently, I take some subnet, I actually had someone do this, and they actually designed this network with some IP address, and I actually used a 16-bit subnet. And that's the amount of 16 bits of it's going to be the hosts. They're added their minds, okay? And they're like, oh, because it makes it easy. Because now what I can do is I can drop every device onto the bus I want, and they're doing it with a VLAN across all intelligence switches, so it makes it nice and easy. I don't have to worry about BBMDs. So and everybody goes, yay! Because guess what? No more calls.
No more routers.
No more routers. No more calls about the BBMD tables are messed up. You know, it doesn't work. Oh, we forgot, right? You just plug it in, it's magically going to work. Now, after hearing what I've been telling you about here, and remember, hanging off all these nodes, you probably got MSTP. You know, buses hanging out there. And I'll have a little more about them in a minute, but, you know, there's probably, let's say, 25, 30 on there. Let's say put 100, 200 devices on here, whatever it is. What do you think is going to happen? You think the broadcast might become a concern here? Somebody tells me that, I go, I don't want to work on it. You guys are crazy.
You're doomed.
You're doomed. So what we like to try and think about, and this is very hard, it's been hard for me to present this based on the knowledge I got from Mike's presentation, but I'm going to give it a try here. So let's say I'm given a project, and I've got some, I can keep some 200 devices. I don't care whether they're IP hosts, whether they're MSTP devices, but they're our masters. And I know out of those 200 devices that I'm going to have 5 groups of 20 that need to intercommunicate for reasons of passing values between them. But other than that, those 5 groups, the only thing that needs to communicate with those 5 groups is whatever SCADA HMI have at the front end. Typical thinking where I am, no fault, there's nothing wrong with it, this is the way people think. What do you think they're going to do? And let's just say it's been nice enough that we've grouped them all into 5 separate VLANs. What do you think they're going to do in the BBMD tables? Anybody want to guess?
It'll all be the same.
Absolutely. 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 So I got group 1, group 2, group 3, group 4, group 5. Yep. And then my BBMDs, I'm going to have entries for, there's a HMI up here, right? Or SCADA, whatever it is. And absolutely, the entries are all going to match. And everybody's gonna point at everybody, and we're all gonna be, this is what I call a linear BBMD layout, because I got the traffic going everywhere. That's great in a small system. We have seen in a big system, this is what Mike was pointing out to us that night, and I'll be honest with you, the light didn't light in this head until about a year and a half later, when things started going upside down in us in the party, and I said, we can't keep doing what we're doing here. What Mike had pointed out to us is, and this is so let's say I measure my broadcast rate using Wireshark, and I found that I have a rate of 3,000 a minute. I'm on a big system, by the way, okay? And because of circumstances, I have to put up with that. Well, what I can do, instead of setting up this symmetrical or linear style, I'm just gonna have the BBMD entries of the front end in this panel. And this guy, I'm just gonna have all the BBMDs out here. And then we're just gonna have strictly have the front end in here. This is what we call asymmetric BBMDs. So now I'm starting to point them and shape the traffic. One of the other tricks that we love to do at Siemens, because we can do this with our software, this is even better. I can actually load multiple device drivers on my box or on other VMs. This is my favorite trick. I'll load multiple drivers. Remember that VM, like this HMI might be actually be running on another HMI or another VLAN. I'll point it to these BBMDs as foreign devices. And I'll hook them all foreign devices with different drivers. That way, back here on the HMI side, I don't have any chatter at all. And when we build a big system that has 5 and 6 and 7 or maybe 20 servers cranking back there, chucking traffic, this stops the traffic that starts beating the snot out of them on the back end as well. These are all battle-hardened tricks that we've had to do. And if we need to do that, this is one of the ways you can mitigate your traffic. I'm a big believer of this. BACnet SC makes this go away. That's one of the beautiful things to it. This is probably, in my opinion, the biggest weakness to BACnet as a protocol. And I don't think it's well understood. And I can tell you it's created a tremendous amount of problems for us, okay? All right, is everybody doing good? Let's go on.
Jack's got a question. Mike.
Sure.
Can I interrupt for a moment?
Sure.
So, since you brought up BACnet Secure Connect, I want to point out that the broadcast problems that you pointed out are not unique to BACnet IP and MSTP. You can have the same problem with SC. If somebody decides that they want to, hang 250 devices on a single BACnet SC network, and then you have your MSTPs off of those, you're going to have the same problem with global broadcasts going everywhere. So we need to use different techniques. Actually, BBMDs would be, BBMDs give us a way to shape traffic on BACnet IP, shape broadcast traffic. I should be specific about that. In SC, we have to use firewalls because there are no BBMDs. We have to use firewalls that are embedded in routers in order to give us the equivalent of the traffic shaping that you're talking about.
Start blocking stuff instead. Okay.
Yeah.
And I'd like to add something to Jim's comments there, because I think what Jim's pointing out is BACnet is a wonderful protocol for interoperability. I mean, I don't know how many have read my bio, but I mean, I started back in the day when Ethernet didn't even exist. I've seen a lot of protocols. I used to work in industrial automation back when Modbus was owned by Modicon and nobody else did it. BACnet is a tremendously wonderful interoperable protocol. And yeah, it's gotten to the point, and SCs do, right? But I'm gonna say for IP and MSTP, 99% of the time, if the guys all go through BTL testing and they'll play nice in the sandbox. It's pretty much plug and play, you know, with a little bit of knowledge needed just to, you can fumble your way through setting it up and get it to work. The problem with it is, because it's so interoperable, people have stopped putting their hats on and doing a little bit of thinking. And in reality, what they can do in larger systems, because it's so interoperable, is I call it, they liken it to building a bomb. And then the next thing you know, by the time they've got this thing erected and the problems start appearing, the way back to fixing it may be very painful. So the point to that is, I see more and more of this now where I get projects sent my way, because again, I do this, you know, kind of system architect role. You know, I get these, like I had a job come my way last week that they're going to BACnet from our proprietary protocol. And they're telling us there's 200 plus panels on there, and there's gonna be even more, you know, and the first thing was, well, what do you think, why would we wanna break them out and do, and you say, no, you don't wanna build a bomb. Okay.
I actually have one, so
Sure.
it might be a bit of a stupid question.
See if I can answer it.
I actually have a fairly loose grasp of what a foreign device is. Could you explain that just a little bit? And as a mid presentation comment, we've got our first building going up that's going to be probably close to 2,000 devices when it's done. So we're starting to, this is very applicable to some stuff that we're working on right now. So.
Okay, my email's it on the last front. I'll be happy to comment. I'm gonna take a shot at foreign device, but I'm also gonna let the guy that actually wrote with me, sitting over there, help me. So, the reason foreign device, my understanding was, foreign device registration was created, was back for dial-up slip connections? Is that what it was, Jim? Back when we used to dial into a system and we finally get a connection. We put IP across there. Because those dial-up connections had movable IP addresses usually, what foreign device allowed me to do if I were a BACnet client sitting down on the other end of that, is I could say, hey, register me with the BBMD. I had to point at the BBMD. Register me. And it would take my dynamic IP, and it would start sending me broadcasts. They're actually unicasts, okay? And there's a time to live on there for the amount of time the BBMD would keep sending them to me. And if I don't re-register, I just stop sending them to you. So it was a temporary, it was a unicast, it was a way to set up unicast communications with a BBMD on a temporary basis. Is that a good description, Jim? Did I miss anything?
Yeah, so unicast and broadcast get a little confusing here. BBMD's purpose is to forward broadcast traffic. When you register as a foreign device, what you're essentially doing is using a unicast message from an IP standpoint, but inside is a BACnet broadcast. So there could be a whois or an IM, which would normally be broadcast. You would normally see it as a broadcast on Wireshark, but now we packaged it inside a unicast message.
Okay, that makes sense. Thank you.
Yeah. So Mike, I bet you've used foreign device in other situations than just dial-up.
Oh yeah, we use foreign device for, like I said, one of our broadcast shaping techniques, it's one of my most favorite, is that I'll put multiple IPs on that box. I'll put multiple, and we call them drivers on our system. I'll put multiple drivers on there, and then I'll put BBMDs across the VLANs, and it registers foreign devices with them. That way, there's no broadcast traffic going on back on down the HMI VLAN. That's great. That's a great thing to do. Keeps all the processing off there. We also love knowing the foreign devices are out there, because when people start complaining to us that things don't work down here, I'm sure you guys have seen, or have Yavi. You guys all use Yavi?
Yeah.
Okay, great tool, right? fantastic tool in my book. Yavi's got foreign device registration built into it. So when I get mischief going on, first thing I'll do, we'll crank Yavi up down here and we'll go connect foreign device out here somewhere and see if we can see the broadcast. Because if we can, it tells us typically everything's great out here and something's going on down here. Quick aside, plug for your BACnet BBMB box. I like, this is off base, but I'll go with it anyway. We at Siemens have BBMB functionality built into our controllers, okay? I don't like that. I've seen more systems broken because people tamper with things they don't understand. Again, go back, like Jim and I, we need a little thinking hat. It has the benefit, I can go in there and tweak it all day long from wherever I'm sitting, but at the same time too, I can tweak it every day from wherever I'm sitting and people break things. Symmetrics has a dedicated hardware BBMD. We bought quite a few of them for the airport. We absolutely enjoy them, they work well, and here was a special trick. We saw a particular vendor, it started with an L, it was a lighting company. It had a big lighting system. When it did its discovery broadcasts, it did not use subnet broadcasts, it used global broadcasts. Remember that one? And that's a no-no. And Symmetrics kindly changed the router so it would pass them across the wire so we could discover them. So even somebody that's a big company like that wasn't doing their broadcast correct. Okay? Okay, here's another case study for you. Was NYU Mercer Street job. The company name was Q. But we won't tell them. The actual physical hardware started with a C because they bought the controller as a product, like a PLC from somebody with their tools, and developed the fan coils, or were they HUs? They're HUs, weren't they? What's that?
Package units.
Yeah, package units, package units. So, imagine this. I think they were dormitory buildings, weren't they?
Yes.
Yeah, dormitory buildings, and they're getting ready to open them up for everybody to go back to school. And the abuse would start, and all the air conditioning and cooling equipment would shut off. Everybody was really happy about that. Around and around and around we go, chasing this one, until it got dumped in oil line. First question we always ask now is, anybody done a Wireshark? Let's look at the broadcast rate. Started leaning towards, yes, it was high. Started doing more captures. It was ridiculously high. But here was the punchline. The reason it would become higher than normal was that I now had the latest iteration of BACnet IP-based terminal equipment controllers hanging up in the ceiling. And there were thousands of them. And when the electrician decided he was going to work on that part of the building, he'd walk over and go clunk and shut all them off. All the rest of the devices that are over here that used to be bound to them for various reasons unknown to me would start chattering about, where have you gone? That added with a few other ridiculous things that were going on, brought the broadcast rate whoop up to that, started getting into that magic number. A couple thousand a minute?
Yeah.
That's about right. 2,000-3,000. And what these devices would do is they, and all of a sudden, boom, they blow up and go away. Here's the best part. The vendor didn't have a clue what we were telling them. The school was getting ready to move students in. The general contractor, who's a good customer of Siemens, said, I don't give a damn what it takes. Siemens, fix it. Fortunately, it got back to the company whose firmware it was, and they fixed it. But before that, we had another fixing game. That's why I want to bring this out for you. Anybody in here ever use MikroTik routers? Okay, if you need a layer 3 RAID, you guys gotta. We use them all the time because they're cheap.
Yeah.
What can I tell you?
They're cheap, yeah.
They're cheap. We bought some $50 layer 3 router. I'm going to say decent product for what you're doing. One of the lovely things about it, it has a layer 2 firewall in it. It has layer 2 firewall rules in it, including a broadcast rate control. So what we did was we took one of their routers, it's operating layer 2, so no fancy layer 3 stuff. Put their firewall, layer 2 in between, and we set the broadcast rate to start dropping. And I forget what the numbers were. I was digging to try and find what it had, the configuration. Well, we put this in our lab between that and the field panel, which is acting as the MSTP router to these QPAC units, which again were MSTP, let's be fair. And we basically took the captures, we played them back through file player and shoved them on it, and we watched it start dropping them. And we told the folks, look, if this becomes a disaster and you gotta move people in for X amount of, and it was a pretty good number, we're gonna make some money on it. We'll put these in between the field panels and those units for now, while you go chase the other people to get your firmware fixed. And they were very thankful. So again, going back to what I said, we're left a lot of times when we're building these big projects, somebody comes in and says, I'm supplying this, I'm the plumber. It's got MSTP in it, that's all I need to know. Well, it drops dead. We're looked at, guys, as the system integrators. Fix it. And nobody wants to hear it. Okay. So here's another one. This one I want to point out. So I've gone through a couple of the examples so far. All right, so the last one we went through, that was an MSTP device with total device failure, that firmware failure, that suicide, you're done. The first one was a flow meter with a company that started with O. That was not only a firmware failure with suicide, front display went dead, it would hang the MS485 bus by those guys, luckily just keeping the bus transceiver inserted. That was nice. Okay, here's another one. This is kind of a sideshow, but we did this one to ourselves. So we had a job, project, a very big project with a very big bank. And the bank had an existing system from a very big enterprise company that they had fallen out of favor with. We had gone in and replaced quite a bit of the legacy system with a brand new Siemens IP system that I'll put on this side. In, I don't know, 400 devices, 500 devices?
Yeah.
500 IP devices. System ran well, system, private network, built by Siemens, everything's great. Over here I've got, company J, who's fallen out of favor, so they're gone. They pretty much come back whenever they pay them enough money. And somebody says, hey Siemens, we want you to go get all these BACnet devices from over here and bring them in over here. Okay, well, what are you gonna do? We're gonna go buy a Symmetrix B3060? Is that the model number?
37.
30 what?
3070, right?
3070, sorry about that. They're great BACnet IP router, okay? But here's where we made a big mistake. We never looked to see what was going on over here. That was a major mistake. What we should have done was literally start up another BACnet driver and isolated it totally from the system that was existing. And what we did was just try to extend this. And when we brought them over, the broadcast flood came with them, and it took the wheels off of everything. The point to that being, and what I can say is don't arbitrarily, at least I learned a lesson, don't arbitrarily take a third-party system and bring it into a BACnet router unless you know what's going on the other side. And I will willingly say I was part of the party who decided to do that. And that was even after getting our heads chopped off in a few other places. So that one's on me.
Well, the danger of that too was that Company J was still servicing their equipment, and they would show up on site, plug in their laptop. They used the network number that we were using on our side.
Oh, yeah, that's right.
Then it
That's another
generated
chaos
this
here.
whole,
Storm.
who is router to network,
I
I
am
am router
router
to
to
network,
network,
and there's
storm.
this conflict that just
And
crushed
And
everything.
it's like just cranking a prop up on an airplane, and then once the broadcast, came way up, all the wheels come off things, and it was just not a good day.
Yeah.
Anybody have any questions so far?
I was gonna say, don't blame yourself, blame Jay.
All right, I have one more example here, okay? And this one was probably started cutting my teeth on before the war had started. It was after I listened to Mike's presentation, which I think again set me in the right place. The company name is E. And what were they making? Variable speed drives. I had a project that had a couple of hundred of them. Big art place in the city. MSTP, hanging off field panels. Think of them as MSTP routers, because it's really what they're doing. They're down these variable speed drives. Now, again, this case is peculiar to what Siemens does, but I wouldn't be surprised if third parties doing some same thing. But up here, I got this HMI, SCADA system that's supervising these. It wants to make sure they haven't died and gone away. So on a random basis of every X amount of seconds, it's not a ridiculous number, it issues what we call a B ping. What a B ping is, it's a BACnet service, read property multiple to look at the device status, it's operational status, I forget, a couple of parameters. And a lot of the thing answers and comes back and the stuff's in range, it says, okay, you're alive. The minute it doesn't respond, or that's really what it comes out, it doesn't respond, after a couple of retries, it'll fail it, and then go back and try again. Well, these things, there's 500 of them, were like a Christmas tree. They would fail, they would come back, they would fail, they would come back, they would fail, they would come back. It was all over the place. And the vendor who supplied them said, not my problem. We said, prove it. They said, no, you proved that we're broken. What it came down to was, there was reasons why the broadcast rate would come up. A lot of it had to do with the, hey, let's disconnect the power to that area of the place and start a, who is, router to network, or who is IAM storm going on. But the bottom line was these broadcast bombs would come along. And these guys were kind enough that when they ran out of space, they didn't blow up and hang themselves. They would just stop responding to you for a while. And then they come back and they had some algorithm and they'd start listening again the next time you poke them. So they would literally die, and literally like 3 seconds later, they'd come back. It'd be boom, boom. So it was like a Christmas tree. They go out, they come back, they go out, they come back. When we finally captured this, in concert with the broadcast rate, which I think the magic number on that one was about 1,500 a minute, it wasn't huge, and we showed it to them, magically they went in, did a little work in the firmware, probably restructured things a little bit to make it quicker, and poof, the problem went away. I'm shocked to hear such things. That's it for me. I hope you guys enjoyed this.
All right.